Okay children, once again welcome back to the online tutor. Right, today I'm going to discuss the matrix lesson. So what is a matrix? The matrix is a rectangular array, right? So the arrays mean, normally the arrays mean the data input structure, no? Right? The main idea is a matrix, right? The matrix is some data values included structure, right? So who found the matrices, right? So actually the matrix is very popular lesson, right, in our mathematics, in our physics, right? The application of the matrices are found in most scientific field, in every branch of physics, including classical mechanism, optics, electromagnetism, quantum mechanism, right? Quantum electronic dynamic. They are used in study physics, such as the motion in the rigid bodies, in computer graphics. They are used to manipulate 3D models and project them onto the two-dimensional screen. In the probability theorem, statistics, right, are used to describe sets of probabilities. Of instance, they are used in the page rank algorithms that ranks the page in the Google search. Matrix calculus generalize classical analytical notation such as derivatives and exponential to higher dimensional. Matrices is used to economics to describe system of economic relations. A major branch of the numerical analysis is devoted to develop the efficient algorithm for matrix computations. The subject is a centuries old, that is today's expanded area of research. The matrix recomposition method simplified computations, both theoretical and practically. Algorithms that are developed using the matrix structures, such as square matrix, right, near diagonal matrices. So I know those things are not familiar for you, right? So you just know only the matrices, some matrices. So what are the square matrices, right? Those things actually in your grade 11, no? So you are familiar for those, right? Today I will describe some few matrices, right, which are using in our advanced level, right? But the matrices is not in from the advanced level, right? We have to develop it, right? So nowadays also they are finding some new things in the matrices, right? But anyway, now I'm going to describe the main structure of a matrix. So here A is my matrix, right? So always the capital letters are indicating the matrix name and the simple letters are indicating the elements. Here A11, A12, A13, A14 dot dot A1M. So it means we have M columns now. And the second row, it's 21, 22, 23, 24. So likewise, it's going to 22M. And so you can so on we can write it like, so assume we have n number of rows, then it will be n1, n2, n3, likewise anm. So this is my last element, right? This whole thing is inside the structure, right? So this is the matrix, right? This is a matrix. So this is the main structure of a matrix. And how many rows and how many columns are there? So here we have m number of columns, right? And over here we have n number of rows, m number of columns, right? Then to convenient of our, right, we are define the order of a matrix. Order of a matrix mean it's always number of rows into number of columns, but we are not getting the answer, right? It's just only the multiplication, n into m. Always the first one should be the rows, number of rows, and the second one is number of columns. This is the order of a matrix. Number of rows, m is number of columns. So assume we have a matrix capital A, it's 2, 3, 5, 9, minus 1, 0. And we have 3 rows no, and 2 columns. 3 by 2 matrix. Assume another one, capital B. It's 5, 9, 3, 1. 0 minus 1, 8, 2, 9. So 3 by 3 matrix. The order is simply number of rows into number of columns. Okay children, this is my content of matrices, right? The first we have row matrices, column, rectangular, square matrices, diagonal matrices, scalar, identity matrix, triangular, nullo zero matrix, transpose matrix, right? This is the content of the matrices. Okay, let's discuss one by one. What is a row matrix? A matrix is said to be a row matrix if it has only one row. So likewise, A equal 4 minus 1 0, B equal 1 2 3. So these are row matrices. We have only one row, right? And column can be anyway, right? It can be 2 columns, it can be 3 columns, 4 columns, right? So we here the example I put only 3 columns, right? The next one is column matrices. What is a column matrix? A matrix is said to be a column matrix if it has only one column. So like a row matrix, no, the row matrix we have only one row. No? Now the column matrix we have only one column. So the again rows can be anyway, right? So it can be 2, 3, right? So likewise, so many rows can be appeared. The next one is rectangular matrix. The rectangular means the structure like a rectangle, right? A matrix is said to be rectangular if the number of rows is not equal to the number of columns, right? So like a rectangular. The next one is square matrix. So this is very important, right? So I know you have learned this in grade 11. A matrix is said to be square if the number of rows is equal to the number of columns. Like capital A equal 9 minus 1, 4, 5. The order is 2 by 2. The B one, it's 1, 4, 7, 9, 2, 5, minus 3, minus 2, plus 1, which is 3 by 3. Right? So I have sketched a diagonal line. Right? So the red one is a main diagonal. Right? The blue one is a secondary diagonal. So we need these diagonals, right, to determine some magnitude, right? So those are only described with the diagonals, right? The main one, the left hand to right hand side, which is main diagonal. Other one is secondary diagonal. Okay, so the next one is diagonal matrix. A square matrix is said to be diagonal if at least one element of principal diagonal is non-zero and all other elements are zero. It's like 1 0 0 0 2 0, right? 0 0 1. So here at least one element should be non-zero of the main diagonal. This is the diagonal matrix. The next one is scalar matrix. The diagonal matrix is said to be scalar if all of its diagonals elements are the same. It's right. So the main diagonal should be same elements, others should be zero. Right. So we can pull the 2 out, right? So it will be again 1 0 0 0 1 0 0 0 1. So you can pull the 2 out. So always the diagonal should be a scalar if all its diagonals other elements are 0, right? The main diagonal element should be same, right? So the next one is identity matrix. A diagonal matrix is said to be identity if all its diagonal elements are equal to 1, denoted by 1. So it gives the similar idea with the scalar matrix, right? Scalar matrix which has any number, no? But today the identity matrix, right? it has the main diagonal as only 1, right? 1 1 0 0 1. So this is 2 by 2 2 by 2 identity matrix. The other one is 3 by 3 identity matrix. Right, so let's move to the next one. Triangular matrix. A square matrix is said to be triangular if all of its elements above the principal diagonals are 0. It's lower triangular matrix. Or all of its elements below the principal diagonals are 0, then it's known as the upper triangular matrix. Right, this is the definition of the triangular matrix. So we'll see what is a triangular matrix is used in an example. The lower triangular matrix, right? So you can see in my 2 by 2 matrix, the lower part of the diagonal, the main diagonal, the upper element is 0. And the bth one, the main diagonal is 1 1 1, the upper one is 0 0 0. So this is a lower triangular matrix. The downward one is a upper triangular matrix. So upper triangular matrix, the main diagonal below elements is always 0. So the up one is non-zero, right? So these are the triangular matrix. The next one is a null zero matrix, null or zero matrix. The null means 0. The matrix is said to be null or 0 matrix if all of its elements are equal to 0. It's denoted by O. All elements should be 0, but it's defined only for the square matrices. Right. Not it can be defined for any matrix, right? It can be any number of rows and any number of columns. The next one is transpose of a matrix. Suppose A is a matrix, then the matrix obtained by the interchange in its rows into column is said to be transpose of A. It's denoted by AT. Right here you can see my all rows are changed into the columns. So a capital A is changed into the AT. 9 minus 1 is the previous A. It was a row, no? Now it's column. 4 5 is the previous one is row. Now it's column. Right? So B as well. 1 4 7, it's 1 4 7 down. 9 2 5 is a horizontal. Now it's down. 9 2 5. Minus 3 minus 2 plus 1. Now it's look like a row. So the columns are changed into the rows, right? So this is the transpose of a matrix. So I will give another idea of the transpose of a matrix like this way. Okay, we can learn the transpose matrix like this way. So assume you have 2 3 5 minus 1 0 9, right? So this is 3 by 2 matrix, no? 3 by 2 matrix. So you just need to find the AT. So what I told you, all the rows are become columns, right? All columns then automatically be the rows. Then your rows will be columns, right? Rows will be minus 1, 3 0, 5 9, right? Now it's like 2 by 3 matrix, right? So you can learn the transpose matrix. The rows become columns, right? Rows become columns and automatically columns become rows, right? So if you have 3 by 2 matrix, the output will be 2 by 3 matrix. But if you have 3 by 3 matrix, automatically the transpose matrix will be again 3 by 3 matrix. Okay, the next we will learn what is a scalar product of a matrix, right? So assume if you have a matrix, right, you just going to multiply A by a scalar lambda. Here lambda scalar value, right? So scalar value, scale, right? So it's like 3 into 2 5 9 minus 1 0 8. Then this is scalar, this is the matrix, right? This is 2 by 3, no? Then the answer will be 6 15 27 minus 3 0 24. So right, so our matrix order is doesn't change, right? The order is doesn't change, but the value, all the values, all the elements in the matrix A is changed to the multiplication value of the own value, right? So this is the scalar product of a matrix. Let's look at a the definition of the addition of two matrices, right? Right. So what is the addition? So assume we have a matrix A, 5, 3, 1, 2, minus 1, 0. The B, 0, 8, 1, 9, 2, 7. Right? The order should be same, right? To add or subtract, right? To add or subtract, the matrix order should be same, right? So what happens if you add A plus B? Then you will get again 3 by 2 matrix. 5, 0 is 5, 0, 8 is 10, right? 3, 1 is 4, minus 1, 9 is 8, 1, 3, 2 is 3, 0, 7, 7. So likewise, right, if you add the elements, right, the corresponding elements, you will get the addition or subtraction matrix, right? So a minus B become again 3 by 2. 5, 0, 5, 2, 8, minus 6, 3, 1 is 2, right? So minus 1, 9 is minus 10, 1, 2 is minus 1, 0, 7, minus 7. So likewise, this is the subtraction one, right? So this is the addition one. So we can add the corresponding elements together to find the addition or the subtraction matrix. Therefore, you just need to understand the only condition to be satisfied for add or subtract to a matrix, right? It was the order should be same for the both matrix. Let's look at another example. Assume you have a matrix, right? It's minus 3, minus 2, 1, 5, 9, 2, 0, 8, 0, right? You have another matrix B, 8, 0, 1, 1, 2, 5, 4, 3, 1, right? So these are 3 by 3 matrices, no? 3 by 3, 3 by 3. So what I'm going to do, I'm just adding A and BT. A and BT. What is this BT? BT means the transpose matrix. The transpose matrix of B. But your A is not changing. It's minus 2 plus 1, 5, 9, 2, 0, 8, 0. The transpose one means all rows become columns. 1, 2, 5, 4, 3, 1. Minus 3 plus 6 is 5. It's minus 1. 1, 4 is 5. 0, 5. 2 is 11. 2, 3 is 5. 0, 1, 1. 8, 5, 30. 0, 1, 1. Again 3 by 3. 3 by 3. So this is not necessary to write always, right? So this is the addition of A plus BT, right? So if you transform the B matrix, but the order is not changed, right? Its own order is 3 by 3 matam. Okay, right. Okay children, let's look at a multiplication of a two matrix, right? So multiplication of two matrix. So the first I'm just introduce how to multiply two matrices, right? So assume we have A and B, two matrices, right? So I'm just thinking this is 3 by 3, 3 by 3, right? Assume you have A1, A2, A3, A4, A5, A6, A7, A8, A9, right? So likewise, this is B1, B2, B3, B4, B5, B6, B7, B8, B9. Okay. So how to multiply this, right? don't write A1 to B1, right? Don't write A1 B1, A2 B2, right? So this is wrong, right? So how to multiply two matrices, right? So it is the multiplication, this one into that one. If you multiply the corresponding order, this matrix, the first matrix is always considering the rows. The second matrix is always considering the columns, right? A1 into B1. A1 into B1, right? And A2 into B4 plus, you have to add it. A2 into B4 plus A3 into B7. If you want the second one, you just cross the first one and the first column into second row. A4 into B1, A5 into B4, A6 into B7. So likewise, if you multiply this way, A7 into B1, A8 into B4, A9 into B7, right? So this is my first column. So we have another few columns. It's the second one and the third column, right? So considering the second column, right? This one into this one, A1 B2, A2 B4, B5, A3 B8, A4 B5, A5 B5, A6 B8, A7 B2, A8 B5, A9 B8. So likewise, we will have another 3, right? It multiplying this and this, this and that, this and that, right? So likewise, all spaces should be inserted but with the corresponding order. So then the answer is 3 by 3 matrix, right? It is 3 by 3 matrix, right? And also you just understand, always the order should not be equal, right? The order is not necessary to equal, but there exists another condition to be satisfied to multiply any two matrices. So I will teach you how to identify the multiplications of the two matrix, right? So what is the condition to be satisfied to multiply any matrix? So hope you will finish that spaces, right? So please finish that spaces, right? Assume you have 2 by 2 matrix like capital P as 5, 3, 8, 1, capital B as 0, 8, 2, 1. I'm going to multiply P by B. P by B, right? Then you can write it like 5, 3, 8, 1, 0, 8, 2, 1. So always first row and first column. 5, 0, 3, 2. First row and 8, 0, 1, 2. First row and second column. 5, 8, this one plus 3, 1. 8, 8, 1, 1. This is 6, 43, 2, again 2 by 2 matrix, right? So this is the way of multiplying two matrix each other, right? Now I'm going to introduce what is the condition to be satisfied for multiplying two matrix, right? here matrix, right? So assume you have A and B. This is AB, right? This is order, right? First one, second example, third example. If we assume the order of the A matrix is 2 by 3, then the order of the B matrix should be starting from 3. 3 by any order, it can be 1, it can be anything, right? Then the answer matrix will be 2 into 3. This will be hidden. 2 into 1. Okay? Assume another one. 1 into 4, but it should be 4 into anything, 3. These two is together, the answer matrix 1 by 3. 1 into 3. Okay? Then we can understand it like, if it is n into m, right, this should be m into any order k. Then the answer matrix is n into k. N into k. So this is the condition to be satisfied of any multiplying two vectors. Then we can learn it like the order of the first matrix, and order of first matrix, column, no? Row column. Column of first matrix should be equal to the row of number of column, number of rows of the second matrix. Otherwise you can't multiply two matrices. Okay, let's assume another example. Assume you have a matrix like 2, 3, 5, 1, 1, 9, and B matrix. So this is 3 by 2, no? 3 by 2, and we will have 3 by 1 matrix, 8, 9, 10, right? 3 by 1. So I just need to multiply A by 2, 1, 3, 1, 5, 9, 8, 9, 10. So the answer will be 3 by 2, 3 by 1. The answer will be 3 by 1. 3 by 1. So 2, 1. I'm sorry. So this should be, sorry, this is 8, 9, no, 3 by 2 now. 2 by 1. It's 2 by 1. 8 into 9. 2 by 1. So therefore your answer will be 3 by 1. So how to multiply? 2 into 1, 8 into 9. It's 16. 1 into 9. 3 into 1. 3 into 8. 3 into 8. 24. 1 into 9. 5 into 8. 9 into 9 into 1. Then the answer matrix will be 25, 34, 33, sorry, 33 and 121. This is 3 by 1 matrix. So this is the way of multiplying any two matrices, right? So they are orders of the row. The order of the column, the number of columns should be equal to the number of rows. That is the main condition to be satisfied for multiplying the two matrices. So now I am thinking you have a better idea of the multiplying of a two matrices. Right? So this is a major part in our matrix, right? You just need to multiply matrices, right, in a correct way. And one more important thing to share with you, right? So assume if you are multiplying A by B, right? So it's not equal to B by A. Right, so assume it's 2 by 2, right? 2 by 2, 2 by 2, 2 by 2, no? Right, these are not equal. So you can't, if the order is equal, it can be equal, but the order of the multiplication way, A into B is not equal to B by E. Right, so it's are never equal, but there exists a one thing, right? So some two matrices giving the same way of the multiplying of a so assume A into B is equal to B, right? This is special scenario, right? B into A equal, right? This is happening, right? This is happening only one time, right? So later on I will teach you what is that one time. So what is that? The one time which gives the AB equal to BA the same answer, right? So but the theoretically you just understand this is not equal anymore. Okay, let's do an example, right? Assume you have a matrix, capital A matrix, right? So it's 1, 2, 2, 3. Find A square, A cube. Right? So how to find this? First, A square means A into A. No? A is multiplied with their own matrix. Into this 2 1 1 1 2 2 4, it's 5 2 3 2 6 8 2 6 8 2 2 4 3 3 9, it's 30. This is done. And how to find A cube? To find A cube, I'm just multiplying A squared by A. 5 8 8 13, got to multiply by 2 3, right? So then the answer will be again 2 by 2. 8 5 into 1 8 into 2 16. 16 plus 5 is 21, right? So likewise this is, it's 34. This is again 34. The last one, (16 plus 39), right? Then it will be 55. So this is A cube, right? So whatever the order, you just need to find A cube, A fourth power, A fifth power. Anyway, you have to multiply it in a correct way, right? First find the A squared and multiply it, then you will get A cube. If you want A4, then A cube should be multiplied by A. If you want A5, you should multiply A4 by A, right? So this is the way of multiplying of any two matrix. Always you just understand here should be the larger one, right? So larger one and the single one, A cube square, not A into A square, right? This is wrong. So first thing is the largest power one, right? It's multiplied by the smallest one. Okay, children, we'll see what will happen if you multiply a matrix by their own identity matrix, right? So this is identity matrix. So assume you have 1 3 minus 1 3 plus 1 minus 1 0 8 2 1 1 2 1 4, right? So I am going to multiply it by their 1 0 0 0 1, right? So the identity matrix of the 3 by 3, right? 3 by 3 3 by 3 3 by 3. So answer will be same order, no? 3 by 3. So then what will happen? 1 into 1, 3 into 0, 1, it's 1. It's minus 1. It's 2. You can see it's only 3. 0. This one into this one, it's 1. this one into this one, it's 8. 2, 1, 4, 2, 1, 4, it's 4, right? So again, A into I, which gives A, no? A into I, which gives A. Let's say this is the very important identification, right? So actually, if you multiply some matrix by their own own identity matrix, so the answer will be same. So identity means only one, no? The identity 5 into 1 is 5, no? So likewise, the 1 is the identity element of the number. That I mean the identity matrix of any square matrix, right? So the category should be same. If it is 3 by 3 matrix, you have to select the I of the 3 by 3. If you have 2 by 2 matrix, you have to select the 2 by 2 identity matrix. So likewise, if it is A into I, then the answer will be A. Very important identification. Let's assume another one. So you have B into I, right? So assume B is 2, 3, 5, 9. I'm going to multiply by their own identity matrix, I. Then it's what happened? 2 into 1, it's 2, 2 into 3, it's 3, 5 into 9, it's 5, 9 into 9, it's 9. So it's 2 by 3 again, 2 by 2 again. Then BI, it's B. So the same thing, right? Okay children, let's move to another important thing. This is inverse of a matrix. What is the inverse of a matrix, right? So inverse, it's very important part in our matrix lesson, right? So assume the definition of a inverse, right? Definition of inverse matrix. So assume if you multiply A by B and also you get B by A both equal to the other, right? A into B equal to B into A into I. The order doesn't matter. The answer is same, it's I. Therefore, right? Therefore, these two, right? Considering this one and this one, A into B gives I, right? So B is known as inverse of A. But if you just multiply B into A, it gives A and property I. Then A is known as inverse of B, right? So this is the inverse, right? Inverse behavior. So actually, the inverse symbol is A minus 1 to the power, right? So A into A minus 1, it always gives I. B into B inverse, it gives I, right? So it's like A over A, no? It's like cancelling, right? So it gives 1 means I, no? So this is the inverse, right? But actually in matrices, we are not considering the division operator, right? We don't have the division of two matrices, right? But the division operation part is acting in a inverse matrix, right? The inverse matrix. So now you just understand how to find the inverse of a matrix when the matrix is given. So like if you have a matrix, right? The A matrix, how to find the inverse of A in A, right? So that is the other important thing. Just assume if you have A like 2, if you have A like 2, 3, 5 minus 1, right? The thing is how to find A inverse, right? Okay, let's before that I'm just teaching you how to find the magnitude of a matrix. Magnitude of a matrix. Just assume A. The magnitude symbol is modulus A. But don't think the answer should be positive, right? It shouldn't be positive, right? It can be either positive or negative. The modulus means the value of the matrix, the final value of the matrix, right? It can be either positive or negative. So some student asked me, so how can be it negative? So modulus, how can be negative, right? It can be negative because this is not a complex number, this is not a vectors, right? This is a matrix. So the modulus of the matrix can be both, right? Can be either positive or negative. So therefore, how to find? This is my main diagonal. This is my secondary diagonal. I'm just multiplying the main diagonal parts. It's 2 into minus 1. And I'm going to subtract 5 into 3. 2 into minus 1 is minus 2, minus 50. Then the answer is minus 70. Then modulus A is minus 70. Right? Then, how to write the inverse? A inverse, right? You just need to set the main diagonal elements. 2 minus 1. The step value is minus 1 and plus 2. And you just need to multiply the negative value of the secondary diagonal. So the secondary diagonal is 5 plus 3, You have to multiply it by minus. Okay? Minus 3 and minus 4. And after that, you just need to divide by the modulus, minus 70. Then A inverse will be minus 1 into minus 17, it's plus 1 over 70. Minus 3 into minus 17, it's plus 3 over 70. Minus 5 into minus 17, 5 over 70. 2 over 17 minus 2 over 70. Okay, so this is the A inverse of a matrix. So first of all, you just need to find the modulus A, right? Modulus A, right? And set the main diagonal elements minus 1 plus 2 and multiply the secondary element by the minus value and divide by the modulus of the matrix, right? But one more important thing, if the modulus is, right? If the modulus getting 0, therefore we don't have any inverse matrix. So that matrix doesn't exist, an inverse matrix, right? Then we don't have inverse matrix, right? So this is very important thing in our inverse matrices, right? If the matrix doesn't have the if the matrix modulus is 0, it's getting 0, then we don't have the inverse of that matrix, right? So always the modulus should be any value except 0. We can discuss it like, assume A is A, B, C, D, right? So modulus A, it's AD minus CB, So we assume it's not 0, right? We assume. So what will happen to the A inverse? You just need to divide by the modulus A and set the main diagonal elements, DA, and minus multiplied by minus. What is modulus A? It's AD minus CB. AD minus CB and D minus B minus C, right? So now you can individually divide the elements, right, by that value. Then you will get the A inverse. So this is the A inverse. So this is the mechanism of finding any inverse matrix, right? So actually this works for only 2 by 2 matrix, right? So actually inverse matrix is only defined for the square matrices. Right? So it's work for only the square matrices. The inverse matrix is only appear on the square matrices, but this method is only work for 2 by 2 matrix, right? And actually in our syllabus we don't have 3 by 3 matrices inverse, right? So 3 by 3 matrices in your university, right? 3 by 3 inverse is in first year of uni, right? So 3 by 3. So actually 3 by 3 inverse is a little bit different, right? It's fine. The method is a little bit different. It is not in our syllabus. It is in our university syllabus, right? So normally whatever you select for the whatever you did, right? It can be engineering, physical science, right? So computer engineering, right? Whatever. In the first year, right? The first year you will learn the inverse of a 3 by 3 matrix. So actually we have the matrices lesson again, right? So because the inverse, the matrices is a very important major part in our mathematics, right? The higher mathematics. In on that matrices lesson, they will teach you how to find the inverse of a 3 by 3 matrix in a proper way, right? But in our syllabus we have only 2 by 2 matrix, so you can find 2 by 2 matrix, inverse of a 2 by 2 matrix. Okay children, now I'm going to solve the simultaneous equation using matrices, right? Using matrices. So before that you just need to follow that AX equal B equation. AX equal B equation, right? So what is this? So A is consisting the elements, the coefficient of x and y. X means the variable, it's x and y. B is the answer matrix. So how to insert this data in the following way? So first is coefficient matrix, 3, 2, 5 minus 3. The next x is the variable matrix, xy. The next one is answer matrix, it's 30 and 37. It's like Ax equal to B. So we just need to find the x matrix. So then I'm going to multiply the equation number 1 by A inverse, right? Always I told you have to multiply it in the front, right? So always the multiplication should be in the front. The introduced one should be in the front, right? Not the here. Then it will be A inverse A x, A inverse B. What is A inverse A? It's I x into A inverse B. So Ix means x, no? A inverse B. So how to find the x, the variables? It's A inverse into B. Ax, A inverse into B. Then I'm going to find the A inverse. To find the A inverse, right? To find the A inverse, we just need the modular same. 3 into 3 it's minus 9, minus 5 into 2, 10, minus 90. And A inverse is 1 over minus 90, you have to separate. Minus 3 plus 3, 2 and 5. Then A inverse will be 3 over 19, 5 over 90, 2 over 90, 3 over 90 minus. This is A inverse, right? So you just need to multiply A inverse by B. So B 7 into 13, A inverse into B. So it's corresponding order. 21 over 19 plus 26 over 90. Thirty-five over 19, 39 over 19. This is 2 by 2, 2 by 1, the answer is 2 by 1. This is our X matrix. So X means X and Y. Therefore, X and Y will be 47/19. So these are the answers of x and y. Always you have to follow this x equal b1, b method. Okay children, this is my next example. So you have to follow ax equal b, no? First of all, this is 4 minus 2, 5 plus 3 x and y. Right, then A inverse A, x equal A inverse B, no? Then x equal A inverse B. This is A, x equal to B. Then x will be A inverse B. So find A inverse, you just need modulus A. Minus 10 is 31. Then A inverse will be 1 over 31 plus 2 minus 5. Then next will be 3 over 31, 2 over 31, 5 over 31, 4 over 31. B mean 460. What is x? This way. Twenty over 31. I'm sorry about that, right? 4 into 3 is 12 now. It's 22. Then it's 2 and 2. Therefore, the answers are x equal to y equal to x equal to y equal to, right? So this is 22, right? So it is wrong. It's 22. So I think now you might have the idea about solving the simultaneous equation using the matrices knowledge. Okay children, this is my next example. Right, let A equal 4, 3 minus 2 minus 1. Show that A square minus 3A plus 2y equal to 0. So how do you state that? So first of all, you just need to find A square. A square means 4, 3 minus 2 minus 1. 4, 3 minus 2 minus 1. This is 16 plus 16 minus 6, it's 10. 12 into minus 3 is 9. Minus 8 plus 2 minus 6. Minus 6 plus 1 minus 5. This is A square. Therefore, a square 3a plus 2y. A square 10, 9, 6 minus 5. 3a means all a's are multiplied with 3. It's 12, 9 minus 6 plus 2y mean, I mean identity matrix, no? 2, 0, 0, 2. Then now you can add it. Minus plus 10 minus 12 plus 2 it's 0. 9 minus 9 it's 0. 6 plus 6 is 0. 15. Sorry, minus 2 and plus 2 is 0. Therefore, it's work, right? A squared 3a plus minus 3a plus 2y is null matrix, right? Okay, so this is the way of showing this kind of results. Now let's move how to find A inverse. How to find A inverse using that property, right? Not with the definition of the inverse matrix. So I'm writing it again. A squared minus 3a plus 2y equal to 0. This is my equation number 1. A inverse is multiplied by the equation number 1. So I told you if you are going to multiply something by minus 1, you just put it to the front. Then it will be a minus 1. A squared is a into a minus 3 a inverse, right? It's actually 3 ia, right? So but this is scalar and a constant, it can be outside. 3a plus 2 is again a inverse I equal to 0 multiplied by anything, it's 0. So what is this? That a inverse and a. What is this? So I told you it's I. What is this? It's again I. What is this? A inverse I is a inverse equal to 0. Now I'm going to subject a to a inverse, which is I minus I a mean a. Therefore, a inverse will be I minus a divided by 2. A 2 is any scalar, right? So you just need to subtract I minus a. I means 0, 1, 0, 0, 1. A means 4, 3 minus 2 minus 1. Then the value is minus 3 plus 2 plus 2. Okay, therefore A inverse will be, it's divided by 2, right? It's minus 3 by 2 minus 3 by 2 plus 1 plus 1. This is the inverse matrix, right, of A. So you can check it with using the other way around. Okay, so this is the hence part of that question. Okay, children, this is my next sum. They already given A and B. It's 2 by 2 matrix. Show that BA equal B. Hence find Z matrix such that BZ equals 0. Here Z is 2 by 2 matrix. So start now. So before explain, right, you just need to find it. So at least one, row number 1. So B, you know, B mean 2, 3, 4, 6. 4, 3 minus 2 minus 1. 8 minus 6 is 2. 6 minus 3 is plus 3. 16 minus 12 is 4. 12 minus 6 is plus 6. So this is B, right? Therefore, BA equal B. How to find the second row? Hence find Z. Hence mean we can use this result. BA equal B. I'm pulling all into the one side. And take P out. A minus 1. So 1 mean in matrices it's I. Right now it's B into Z. No? Therefore Z will be A minus I. What is A minus I? So I mean 1 0 0 1. A minus I mean 1. A minus I. 4 minus 1. It's 3. 3 minus 0. It's 3. Minus 2 minus 0. It's minus 2. Minus 1 minus 1. It's minus 2. This is my C matrix, right? C matrix. So only thing is I put B out, right? And pull. I shift B left hand side and I pull B out. So hope you all okay with that sum. Okay children, now you can see on the screen the next sum was taken from the 2013 area paper. The let Q equal 1 minus 1 plus 1 plus 1. Find the value of lambda, it's a real number, such that QT Q equal lambda I, where QD is the transpose of Q and I is the 2 by 2 identity matrix. Hence find the inverse of matrix P. Let A be 2 by 2 matrix such that AP equal PD, where D equal 2 0 0 8. Find A. Okay, I'm just starting from the first part, right? So Q was also given. So Q was given me. This is Q. 1 minus 1 plus 1 plus 1. Then what will be QT? The transpose matrix. All rows become columns. Then QT into Q. 1 1 minus 1 plus 1. 1 minus 1 1 1. So this way 1 1 is 2. 1 minus 1 minus 1 0. Minus 1 plus 1 minus 1 0. Plus 1 plus 1 is plus 2. Actually you can pull 2 out. It's 1 0 0 1. Right? It's like lambda I. No? So lambda become 2. And also hence find the inverse of matrix P. So the lambda mean 2 me Q T into Q. It's 2I. So how to find the inverse of P, right? Using that result. So what is P actually? P mean 1 over root 2 minus 1 over root 2. 1 over root 2, 1 over root 2. The Q was 1 minus 1, 1 1. So you can see here the only difference is P is divided by root 2. P is divided by root 2, right? Then we can stay two as root 2 into root 2 I. So I'm shifting to the root 2, 1 over root 2, Q equal up, right? So this is 1 over root 2 qt 1 over root 2 q equal that, right? So this is like P, no? This is like P inverse, right? Anyway, so what is qt? It's 1 over root 2 minus 1 over root 2, 1 over root 2 and 1 over root 2. What is, this is actually q, right? What is qt? 1 over root 2 minus 1 over root 2. 1 over root 2, 1 over root 2. So actually, this is q, right? Q mean p. So this is p, right? This is p, right? This is like p inverse, right? So I'm just putting 1 over root 2 minus 1 over root 2 plus 1 over root 2, 1 over root, right? So this is qt, right? So it's 1 over root 2 plus 1 over root 2 minus 1 over root 2 plus 1 is I. So this is P actually. This is P inverse, right? So therefore, P inverse 1 over root 2, 1 over root 2 minus 1 over root 2. Right? So actually we can write it like 1 over root 2 q. This is my P inverse. That is what they ask. So this is hence, right? Hence, that is the problem. The other part, let A be 2 by 2 matrix such that AP equal PD, where D equal 2, 0, 0, 8. Find A. Okay, we have to find A, no? And D also given. D was 2, 0. A, I assume A as A, B, C, D. A, B, C, D. P mean 1 over root 2 minus 1 over root 2. P mean again 1 over root 2. 1 over root 2 minus into D mean 2, 0, 0, 8. 2, 0, 0, 8. Now we can cross multiply it. These two, this one. It gives A root 2 plus B over root 2. C over root 2 D over root 2 minus A over root 2 plus D over root 2 C over root 2 D over root 2. This is same with these two. 1 over root 2 2 over root 2. Minus 8 over root 2 plus 8 over root 2. So now you can equal these two, right? So you will have 4 simultaneous equation, and actually it's easy, right? Because if you are equaling these two, root 2 cancel, no? Then A plus B equal to minus A, B minus A will be minus 8. C plus D equal to and D minus Z will be plus 8. If you added these two, A cancel, B will be minus x is minus 3. A will be plus 5. If we added these two, D will be 5. So D 5 means C will be minus 3. 5 minus 3 plus 5 and minus 3, right? These are the answers of C and D. Therefore, your capital A matrix will be A, B, C, D, 5 minus 3, C minus 3 plus 5. Actually, it's cool, right? Okay, children, this is the end of the matrix lesson, right? So I did all the theories, right? I did all theories and all operations with the matrices, and I also discussed some advanced paper questions as well, and I put some homework questions to be done, right? So you can try it. If you have any doubt, please contact me and ask me, right? I'm happy to answer your questions, right? And further, so now actually the complex number lesson and the matrices lesson are over, right? The complex mean the all theories have been finished, right? But I will discuss more questions as well, right? The next tutorial I will discuss some examples for some past paper questions, right? And some student request me some questions, so I will put those things in the complex number tutorial, right? So what I am going to tell you, so the matrix lesson and the complex numbers are coming with it together, right? It's always the question number 13, right? So now you can do the that question number 13, right? Question number 13, and in the past paper questions you can start from the 2011 and one by one finish up to 2019, and do the model paper questions as well, right? So the 2019 they have launched the model paper no? Then you can do the model paper questions with including the matrices and the complex numbers. So actually what I'm going to tell you, so now the one essay is completed, right? So one essay is completed. It's up to you to practice those things. It's up to you to memorize all the theorems in these two lessons, right? So these are mathematically it's easy, that you have to understand the patterns, right? So after that, so I will have to upload some probability lessons as well, right? So actually we did only 2 tutorials, so we have another 3. So, and I will catch you with the probability tutorial number 3, right? So thank you very much for being with us, and have a nice day. Bye bye.